All right, we're back with our luxurious rocket. I wanted to talk about today. I know we just went over the basics, but I really wanted to talk about truly optimizing. Now, we looked at OpenRocket's optimization tool, which is great. We saw it wasn't perfect, but it really does help in tacking on, some some beneficial aspects of this rocket. But I also want to talk about some other things I kind of glanced over last video. So first of all, I didn't even go over the fin thickness. Now, this is pretty much always, you know, always something you design for, but you certainly don't want to forget it. So it's really a solid thickness would be something like a quarter of an inch. As you can see, the thicker the fins, the lower the apogee, but the sturdier they are. You really don't want fin fluttering, and many of the attachment methods we give it are things that will prevent fin fluttering. Uh, so there's all sorts of things that will affect this altitude. And by being real with ourselves, we can really get a realistic altitude. So first of all, our thickness is one of them. Whatever you can get away with, being thin enough, you want to go. So we'll say 0.25, we'll say 0.2. It really depends on all sorts of stresses. Now we went over our component material. However, we didn't go over this paint finish. Now this paint finish can be for every component. And here we can set it for our fins. So as you might have guessed, the smoother our paint on the outside, the better it's going to glide through the air, and the less drag we have, meaning the higher we'll go. This of course means that if we have it polished, and by polished I really mean so you can see yourself, you see that already adds quite a lot of altitude when it's just our fins polished. So we can actually set that for the whole rocket, and it shoots up. If you really pay attention when you're painting and you do a great job, you're going to see the results. We talked about attachment methods. Now, I wanted to go over fillets. If you don't know what fillets are, it's right here between the fin and the body tube. We apply these fillets of epoxy. We use JB Weld. That stuff holds on like nobody's business. But we really use that because it helps increase our surface area of attachment. Not only do we have that, we have attachments down here. We have all sorts of things. So if you want to actually specify that fillet, OpenRocket is very in-depth. So we could say, hey, we have a fillet radius of 1 inch. And our fillet material, I add our epoxy. This isn't really its density. It's kind of like just a good guess. 0.1 ounces. I actually don't know if it's a good guess, but it is a guess. 0.1 ounces, and you can account for that, the weight, whatever it brings, all sorts of things. Finally, before we leave our fins, we can talk about our cross section. Now, you may have guessed that anything that's flying, you never want a blank face hitting the air because that's going to sacrifice a lot for you. So rounded, it's just as it sounds. You basically sand the front of the fins so that it's rounded, it slides through the air better. Airfoil, it's actually designed to cut through the air. Wings are airfoil shaped. All sorts of things that we launch into the sky are airfoil shaped. Doesn't need to be perfect, just if you could make some kind of cross section where it's like stabbing the air, that's better. So you can really see a fully optimized, well-built rocket with airfoil fins. You just added another 4,000 feet to your apogee. You keep your fins to a minimum thickness. You add your fillets, make sure it can handle it. You're looking pretty. And you paint well. All right. Yeah, and then for the sake of optimization, I said we could run an experiment with the boat tail. You may not even think it means that much. So we're looking at 37.5 K feet. So we can go ahead and take away our boat tail, and we drop all the way down to 30. So the boat tail is certainly, it's in your best interest to have, and if anything, it increases your surface area so that, this challenge of always bringing back your CP, it gets a little better, it gets a little easier. And if you didn't notice when we were optimizing our fins, by sweeping them further back, we pull the CP even further back, which is always something you want to look for, especially when we don't have some kind of payload up here. So I hope that was informative, and I'll probably see you in a video very soon.